Hey everybody, hope you had a great weekend. We're going to continue with 9.6 today, solving systems of nonlinear equations. If you remember on Friday we solved by graphing. Today we're going to solve by substitution elimination, just the same way we did with systems of linear equations. You know, there's those three methods, and so we're going to now use these other two methods of first substitution and then elimination. So with any of these, you can really choose which way you want to do it. But we have these two equations. This is quadratic, this is linear. It says solve the system by substitution. So what I'm going to do is if y equals x squared plus x minus 1, that's what this y equals, then that's what this y equals. So I'm going to substitute in this information. So instead of writing y, I'll write x squared plus x minus 1 equals negative 2x plus 3. Alright, so now I want to get everything on the same side so I can get equal to 0. So it's a quadratic equation equal to 0, and I have lots of methods I can use to solve that. So I'll add 2x and subtract 3 from both sides. So that means I'll be adding 2x here and subtracting 3, giving me x squared plus 3x minus 4 equals 0. Now we have lots of ways that we can solve this. We can solve by factoring if possible, graphing, completing the square, taking square roots, quadratic formula. Any of those ways are possible now because we have something equal to 0. Quick look at it, I noticed that I can factor this out because two numbers that multiply to negative 4 and add to positive 3 would be x plus 4 and x minus 1. So my answers for x will be x equals negative 4 and x equals 1. Now, since we're talking about points of intersection, we don't just want the x values, we want the y values. So I have to take this x value and plug it into one of these two equations. The linear one on the bottom would be easier for me. So negative 4 times negative 2 is 8. 8 plus 3 is 11. So my first order pair is negative 4, 11. And when I plug in 1, negative 2 plus 3 is 1. So my other point of intersection is 1, 1. So those are my solutions to this system. So here we use substitution. And just like with system of equations that are linear, when we did it, we could also solve by elimination. Elimination with those, we had the x and the y on the same side. Here what we're going to do is we're just going to subtract it the way that it is. So if we subtract this bottom equation here, what's going to happen is y minus y is 0. X squared minus, well, there's no x squared, so there's no like term, so I'll just have x squared. And then negative 3x minus negative 3x would be negative 3x plus 3x, that's 0. And then negative 2 minus negative 8 is negative 2 plus 8, which is 6. So the fastest way to try to solve this would be to subtract 6 from both sides and solve with square roots. So when I subtract 6 from both sides, I get x squared equals negative 6. Well, now what do you notice? I have something squared equals a negative. What number squared is going to be a negative? Are there any numbers squared that are going to be negative? No. So what's our answer? Our answer is no solution. Now what does no solution mean in this context? It means that these two lines do not intersect. So the quadratic and the linear function do not intersect, so there's no solution. So that would be your answer. So we solved this one with elimination. Now with these problems here, there's 6 problems. I want you to decide which way you want to solve it and solve the 6. So pause the video, try these 6 out, and when you're ready to go, you can play it, and you'll see the answers up on here. And if you have any questions, remember to write them down on the Google Doc. Alright, so the answers for 1 through 3 are here. I used substitution here. I got x squared equals 0, so I got 0, 9. That's the only solution that there was. For number 2, I again used substitution. I wound up using factoring. I got x equals -3 and x equals 1, so it was -3, 15, and 1, -5. And for number 3, I chose elimination. When I got down to this, I decided to do the quadratic formula. And when I got to this step, I looked at the discriminant, and I saw that that was going to wind up being negative. So remember, when the discriminant is negative, the value inside of the radical sign being called the discriminant. If the discriminant is negative, there's no solution. So this had no solution to it. So the first 3, 0, 9, -3, 15, 1, -5, and no solution. Alright, and number 4, I decided to solve by elimination. Again, I got x squared equals 5, so x was 2.2 and -2.2, and so these are the answers that I got. For this one, I wound up using the quadratic formula. For x, I got 1/3 and -2/3, so I got 1/3, -7/3, -2/3, -22/3. Those were the answers for that. And for number 6, I again used the quadratic formula. Notice that the discriminant was going to be negative, so I knew there'd be no solution. So these are the answers for 4, 5, and 6. You could have solved it any way you wanted. If you decided to choose a different method of solving it, that's fine. But yeah, those are the solutions that I got. If there's any questions or if you disagree with my answers, please write it down on the Google Doc. Alright, so now what I'd like you to do is please go to Big Ideas Math and work on those problems. If you have any questions and you want to talk to me about it, make sure you set up a Google Meet. Otherwise, have a good rest of your day. Alright guys, bye.